Hello, everyone. Welcome. Thank you for joining today's session. My name is Isabel. I am an event planner for the Reactor, joining you live from Sydney, Australia. Before we begin today's session, we have a quick housekeeping. We strive to create a welcoming, inclusive, and supportive environment for both our audience and presenters. While we absolutely encourage engagement in the chat, please let's keep all comments respectful, professional, and constructive throughout today's session. This session is being recorded and will be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. And if this is your first time attending a Microsoft Reactor session, please note that you must create a YouTube account in order to have access and interact in the chat. You can set that up now. If you have any questions, please feel free to reach out to us on social media or through the Microsoft Reactor website.
Welcome to New Breakpoint, Microsoft's digital event series designed for developers by developers. I'm your host, Michelle Sanford, the Developer Engagement Lead for Australia, New Zealand and Asia. We broadcast on the second Thursday of every month, and if you join us on the day, my guests and I will answer your questions live in chat. As you might know, New Breakpoint has expanded to encompass Asia Pacific, meaning we will now bring interviews with developer experts from all over Asia. Today, we are welcoming Daniel Fang from Insight. Daniel is a senior architect at Insight Australia. Hi, Daniel. Thanks for joining us. We're excited to have you here with us.
Thanks, Michelle. Thanks for having me here.
Why don't you tell us a little bit about yourself and your role at Insight?
Sure. I joined the Insight about 2 years ago. I'm currently a senior architect, and we are doing a lot of work on Azure. My role is more about integration, and also we are running a lot of workshops to promote Copilot, GitHub Copilot, and AI workshops as well.
Oh, that's cool. But what you're bringing us today, while you have been talking about it in the workshops that we've been sharing with our customers, we did a whole series last year called App in a Day, and that was where I first saw your Lego stuff. This actually came out of a project that you were doing with your children. Is that right?
Yes, 100%. So what happens is that my daughter's high school team, they join a robotics competition every year. And when they went to school and pick her up, notice, the kids have so much fun with all the Legos and they're building a robot and they can write Python code to control the robot, then join the competition. So that's why I joined them as their volunteer coach and then spend the last 2 years helping them running the program. And then also thinking about how I can build something for them to learn Python. And then that's what I did last year to start with. I built a chatbot. So the girls, they're able to learn Python syntax and start to finally writing some Python code and then try to prepare for the competition. Yeah, that's how everything started.
I think it's such a good idea because when I first learned to code was way back when I was doing my master's degree back in England. And that was really hard because we didn't have the internet back then. We had these things called books that not everyone has heard of, but that was the only way we could learn the code. And it wasn't fun. We were learning C++,
That's hard.
Prolog, which I liked, Lisp, machine language, all of those things, but there were not fun ways to learn it. Whereas these days, whenever I try and learn something, I always look for, is there a tutorial aimed at kids? Because they always teach it in a fun way.
Yeah.
And that's what you've been doing with your daughter, right? You've been helping her learn something essentially quite difficult, but in a fun way.
Exactly, because what we found is all the kids, they love Lego, and with the robotics, they actually can see Lego pieces start to do something, performing tasks in real life. And then they start to think, are we able to ask the robot to do more things than what it can be done from the tutorial sessions, and then start to look into some coding. They typically start with a stretch, it's like drag and drop. But for the high school kids, they start to learn a bit more, see, oh, I see how the professionals are doing their writing Python code. So are we able to start to transition into the Python code? But the reality is pretty hard, especially in school. They don't really have coding mentor around to help them all the time. They only have like a 2-3 hour robotics club once a week, and then a lot of time at home they don't really have anyone can help them. That's why I started. Maybe that's a good thing if we can use AI. We build a coding chatbot for them to start with. At least they have someone they can ask a question and then try to learn, explore themselves. That's pretty much how we started last year. Yeah.
So the chatbot itself is helping them learn. It's teaching them. They can ask questions of the chatbot and it will explain stuff to them.
Yeah. And also for Python, they need to understand what the commands the robots can accept. It's like a rotating the motor, etc. So they need to kind of ask questions to understand. To move the robot forward, you need to spin one wheel backward and the other one forward. Otherwise, your robot is spinning rather than moving it. So a lot of things like, and then also it's a real world kind of robot. So you're actually able to see things happening. Is your code actually working, or you have some bug in your code? So yeah.
That's a really good point because obviously a lot of our customers are working in, well, like mine sites, for example, where they have autonomous vehicles and where they might be remotely controlling vehicles. What you've built with these kids is kind of a mini fun version of what their parents might be doing in the real world, right?
Yeah. Actually, I got a ping from one of our account managers because she see my videos of the logo robot and she asked, do you want to come and talk to our customers? They are building some real world robots. I say, probably not at this stage. I'm all kids play at the moment. So yeah.
Oh, Daniel, you know you're always supposed to say yes when people offer you an opportunity. Imagine if you what kind of robots you could see in big business, and then how you could tell the kids about that.
Yeah, that would be awesome.
How old are the children doing this competition?
Yeah, my daughter is 13, so year 8. So I think the program, they have different levels. So the earlier stage is from like year 4 to about year 9. But they do have a later stage, which is more engineering. They are not building logo robot, but actually mechanical robots. So that's until like university. Yeah.
How old are they at year 4?
Year 4, I think it's about age 10, 10
Age
to
10.
16. Yeah.
Because I often talk about the Coder Dojo Club where kids will start from age 7 until 17. So I always say it's pretty much never too early to start your kids learning to code. But what I like about your story is you weren't just teaching your daughter how to code, you're enabling her to build something that is in fact a mirror of what people are building in the real world, of what her father is building, of what other parents are building. And so where parents are thinking they don't have enough time to spend educating their kids because they have their own work to do, in fact you can combine the two things, really.
Exactly. That's what I'm very happy about. And also, I finally convinced my daughter to go with me for the next weekend volunteer event. So there's a robotics event coming up next weekend. I finally convinced her to go with me. So we will go there together, see how we can help with the event. And that was kind of a tech challenge. It's similar robotics, but more engineering. So yeah, it's a good time to spend with her.
Oh, fantastic. Well, the robot that you built and the demos that you showed at AgentCon a few weeks ago were really taking everything to the next level. You were starting to talk about Agentic AI when you were showing that off. What are you gonna show us today?
Yeah, sure. I think I have built a few agents, and this agent is doing a particular part to control the robot. For example, I have one agent that is able to actually send out command to the robot. You can see robot moving. Also have a different agent is able to do the vision. So it goes through a camera, able to detect the object on the robot table. Then finally, also have a few other agents. They can kind of receive your voice, speech, and then it is able to coordinate with all the agents working together. So in the end, build a Go-based agent. You can ask a question, give the robot a command, and all these agents they are able to working together, try to achieve something. For example, in my case, when I started my Go year, the robot is able to grab a Coke bottle and then able to send to some logo minifigures. So that's probably what I did. Yeah.
Fantastic. Well, do you want to show us some stuff?
Yeah, surely. So maybe I will start with this agent. I think that's the goal we want to achieve in the end, and that is where I start to build the agent for my Rogo robot. And at that time, the Microsoft build last year just finished, and then I was quite inspired by two of the sessions. One from Scott and Mark. They actually used the real world robot with wheels, able to kind of grab a Coke bottle. And that's where in this video you see the Coke bottle coming from. Also, there another breakout room session. It's from Seth and Amanda. They build a very interactive UI, which I will show you later on. That's how actually feedback I used their repo to build a bit more, able to have human in the loop and see everything happening. And that is how the sales pitch. So you only need to give a command saying grab the Coke bottle and send to the logo family, to the browser family, and then the robot is able to perform that for us. And then we also have a user interface around that. It is able to receive different commands, which I will demo in a second. So that is the end goal, but it's not that simple to set up, because when I started, we need to actually have the space to carry out all the works. In my case, yeah, we have a logo room in my place. You can see the robot is on the screen, sitting on the table over there. But also I set up a camera, which will provide the vision to the robots. Then it connects to a laptop, which will send out a video feed to my other laptops where I can do all the coding work. And then to get everything working, there are also a lot of challenges. For example, you can see we have a big window there. I noticed actually the lighting and on this object on the logo table can change a lot of things. For example, the object no longer be able to detect if the light is too strong, or at the night time you don't have any lights. So there are quite a lot of around. I never thought of it's an issue, but when you actually try to working on a real world robot, found out, oh, these are issues. You need to think about it. And one thing in particular fun, because I'm trying to make the agent able to receive voice input, and I have to talk to the app and then giving command. And one day my son, his bedroom is upstairs, and he asked, Dad, I heard did you have a new girlfriend? I heard the female voice in your room all the time. And that's the thing I never expect, because I thought, oh, I've been always writing code. Saying, where is that coming from? And then I noticed, oh, the voice I've been using is a female voice. So that's why my boy thought that way. So a lot of interesting things happening. Yeah. Cool. All right. So that's our logo table. And probably I will get started. Where I started is start something very simple. So started having an agent, a very simple agent. It's just like a chatbot. And what you can do is ask questions. It has some instruction defined, and it use a GPT model under the hood. And then gradually from there, I start to add more tools. For example, it can actually send a Python code via Bluetooth to one of the robots, and the robot will be able to perform different tasks. And then also I build a YOLO image recognition model. It is able to detect where is your robot and also the target you want to achieve. And then start from there. That's the first agent I built, as in adding more agent to it. Try to say each agent have a different role into the final solution and how we can have them working together. So basically that's how I started. Yeah. And then I look more into it. In the end, what we are hoping to do for the logo agent here is just think about that as a person, because the agent they need to do what a human being can do in the end of the day. You give it a command, it needs to see what's happening. For example, it needs to know the position of the logo robot on the table, and then also need to see where is the target. And then it can calculate the distance between the two. Then also the robot agent able to kind of talk to human like a conversational style. it is able to receive commands from your speech and then get back to you with voice as well. Then further to that, we need a planner agent. So the planner agent can convert all the distance into different commands the robot is able to perform. For example, it can move backward or forward, it can make it turns, and then it can open and close up when it's close by to the target. Then further to that, most importantly, the robot need to have arms and legs. It can move around on the table, logo table. It can also perform different kind of actions. For example, grab the object and then release the object, etc. But that's all these are just individual actions. We also need to, for example, have a judge agent to be very critical to see if the goal is met or not. If it's not met, the other agents need to working together again, try that again. And then finally, we have an orchestrator agent as well, making sure all the agents are working together and they knows who need to do what after which agent, so that everything will hopefully just working together. Yeah.
Okay. That's really complex. So it's not just that it tries to do the task and then it can't tell whether it's done the task or not. It has to judge whether it has correctly completed the task, and if it's not, then it has to try and find some workaround or some other way to continue until it has completed its mission. Yeah, that's really well, I mean, that's what you want in the real world, absolutely, but it's not at all what I would have thought of when I'm building Lego things. I just kind of centered on its journey, and then when it, fell apart or exploded, I was just like, oh, well, we'll start again. But yeah, you really have taken it to the next level.
That's exactly my feeling when I started. Like I thought, oh, I only have times during the weekend. Like when you look at this one, there are quite a lot of things involved. But the good thing is that when you really started looking at them and try to break them down one by one, you found out, oh, actually it's not too hard because all the code you have currently may not relate about the LLM code. It can be all the code you have in the past. All this code, you can just simply reuse them. For example, you want to build a image model so that it can see where the robot is. So we already have so many good machine learning model. In this case, I use the YOLO model. It can do this for you already. You do not need to reinvent the wheel. And also, I found a big time saving for me is I use the GitHub coding agent. Like it's the first time I'm really using it. For example, building the YOLO model. I thought I'm gonna spend days on it, but in the end, I just described all my requirements, saying you need to detect colors, found out the image, then convert that into XY axis, and then send that to the coding agent. It gets all the majority of the code done for me in about 30 minutes, and I'm really impressed by how much time it saved for me. So someone never really wrote any code for YOLO model, but see something actually functioning, I can keep improving on it. Yeah.
Yeah, I'm definitely like when I'm teaching people about learning to code, I'm absolutely saying, don't be vibe coding. Don't just be letting the agent do everything for you. You need to understand what is going on in the background. You need to be the one in charge of the architecture. You need to be making the plan. But I also have been using the GitHub agent mode a lot, and it is speeding things up for me a lot. But it's like mostly the infrastructure that I don't like. I've been creating a bunch of workshops, and it has just, I will just say I want to commit this all to GitHub. I want to pull any changes back from GitHub before we go. I want to build it and deploy it. Can you just do all of that for me? So all the infrastructure part, rather than me putting in the individual Git commands, trying to think what is the order I put them in, typing them all in one by one, I just say, just commit this, push, deploy, build, go, and it does it. And so, it sounds like that's not a big thing, but in fact, it is a huge time saver.
100%. And it saves a lot of time. Otherwise, you're spending a lot of time trying to work these scripts out, getting all the commit done. You're basically not focusing on what you really want to build. Actually, build all the integration, build the app itself to do something that AI can help you. Yeah.
I've been really testing as well what like how smart it is. So when I'm putting images into a workshop, I will often just upload the images to GitHub, leave them there, and then I would be editing maybe in code spaces or in Visual Studio Code. Well, in truth, I'm always using code spaces these days. And initially I would then look up what is the path for those images that I have put, and then put them into the code, write them in and all of that. Yesterday I just did a bunch where I said, I wrote the workshop, I put placeholders for each of the images, saying like image of of GitHub doing this, image of GitHub doing that, like just like a description in there as the placeholders. And then I said to agent mode, go through, find the images and update those references to the correct path. And I didn't think it was going to be able to do that for me.
Yeah.
And I said, if you can't find them, tell me and I'll clarify which image is what. Because I didn't give it the name of the image or anything. And it just went through and did it for me perfectly. And I was like, wow.
That's awesome. Cool. Yeah. And just on that, I also found a good, interesting thing when I built the LEGO agent. So I used the GitHub Copilot, try to be the control console panel. Which let me show you. I think that one is quite interesting because I was doing some proof of concept. One big question I'm not quite sure is the MCP protocol actually able to control the robot, and then based on the command you put into the Copilot is able to invoke the, that's the stop. So one thing I was wondering is if I'm able to use the Copilot, it is able to connect to an MCP service. Then the MCP service is all my Python code to interact with the robot. So that will be able to help me do a quick proof of concept, because in the end, that's the gut of the whole solution. We are able to control a robot display based on natural language. And on that, so let me do my very first demo. 1 second. Okay, so what I did is I have this my code repo. Let me zoom in a little bit. Okay, so one challenge or one thing I was not sure when I first started is how I'm able to actually build some commands in here, and then how the Copilot on the right-hand side is able to pick up all the actions I built for the logo. So in this case, what I did is I used the MCP library. So that MCP library is able to start an MCP server locally. And then all I need to do is I can define a few MCP tools. For example, pick up what are the robots available. But the more fun bit is it can also directly control a local robot. For example, in this case, that tool is moving robot backward, forward, and then it will only taking like 2 parameters, which robot it is, and the actual distance. And then I did the same thing for a turn, and also it can do beep, or I feel moved arm as well. But all the parameters is what the language model is able to understand. It knows passing 1 means opening the arm, then passing 0 means close the arm. And then under the hood, how it interacts with the robot is it will have a block of Python code. And that Python code in the end will be sending to the robot, which I have hosted in a local server. So in the end, the Python code is posted into the robot via Bluetooth, and the robot will just run the Python code. But the real fun part is, while I was doing the testing, what I did is I created that service, and then I put that into the Copilot in the VS Code. When I go to the MCP configuration over here, that is all I need to do to allow the Visual Studio Code and the Copilot to pick up all the MCP function I defined. So in this case, if I run that, it's running. And then if we switch to the Copilot, GitHub Copilot, you can see under the configuration tools icon, it straight away pick up. I have a few logo commands available. Here we go. So that's the one I just built. It can move arm, do beep, and move and turn. And the magic bit is now it means I only need to give you instructions in my GitHub Copilot, and the Copilot is able to perform different robot actions for me. So let's have a quick look. So the first thing I need to do is, okay, so what I did here is we remote desktop to my laptop next to the logo table. And I will start the local video streaming. And then on this side, I will also start the server side. And then basically we have a video streaming of the Lego table showing up here. And we can see how the logo will work out. Okay, so that's the eyes. We can see what's happening over there. But also importantly, I will also start the Bluetooth service of the logo robot. So that is where the logo robot receive all the Python commands. So it is now connected via Bluetooth. And then let's see if it's gonna work out. What I will do is I will say, move robot forward 10 centimeter. And then once I send this one out, the MCP protocol will reach out to the code I wrote and send a Bluetooth command into the robot. So right now, the Copilot already ran 2 commands. The first one, see what the robot's available, and the robot moved forward a little bit. So that is how, actually, it's a very easy and quick prototype for me to see that thing's gonna work. Do I have the connected to the robot and it is able to perform different tasks? But then let me try a harder one. So I have a few chained command, and let's see if we can have multiple actions happening at the same time. So what I did is I will clear that. And then now I'm saying move forward, then backward, then turn around, open arm, then close it. So I send the whole instruction in one go to the Copilot. And like earlier, Copilot is able to understand and break down each command into different 2 calls. So the first thing is it will move forward and then backward 20 centimeters. Yep. And then should turn around 360 degrees. Great. Then finally it will close arm, then open it. So it opened a little bit and then closed a little bit. And then the magic bit is all the language model is trying to understand the function to call and also include the parameters. For example, for that turn command, it picked up, it needs to do 360 degrees, and that's the robot ID, which we can see from the video on the right-hand side. Yeah, so that is pretty much where I started, and I see, okay, actually this thing might work out. I can establish a physical connection, and then the robot is able to receive Python code and perform actions. Yeah.
That's very cool.
Yeah, good. And that's where I keep going. So that's the first challenge I thought. We have a controller agent now. It can control the robot and perform actions. But that's only step 1. The next challenge I had is how, because right now I'm giving all the commands saying you need to do each action, how far you need to go. But in reality, to make the agent fully autonomous, it needs to able to see the object and then perform different tasks. So that's why I kept my development going. So the second one I built is, it is the object recognition. So if I go to my local code, I will go there. What it does is, if we have got an image like this, pretty much is very similar to the logo table on the right-hand side, is the code or the agent able to see we have a robot here, and then also we have a red object over there, then do the calculation, figure out what's the distance between them. So what I did is, we did our very first code block here, and it is making use of the YOLO model. What it does is, if we take a look at the code, it's fairly simple. We are using Semantic Kernel, and then we define the agent here. And then inside that agent, it does a few different things. So the first thing is, it will talk to the Foundry agent service, try to create a Foundry agent. Then you are passing the model. You set temperature 0. In this case, I would just want everything as it is. Then we have some instruction here. Took me quite a while to cover different scenarios in the agent, instruction. Then the very important bit is we define a plugin. So that plugin is getting the video feed, able to take a photo out of the video feed, and then it run the YOLO model under the hood. So if we take a look here, so that's the plugin we have, and it only have one kernel function called get the field stats by camera. Then it is a remote feed service. We call that API to give you an image back. Then we run the YOLO model. Basically, it's the processing image. It is able to give us a JSON analysis back, saying what's the position of the agent and how far away they are from each other. But let's try to run it. So if I run this one, see API, Python test, the YOLO one. I'll zoom in a little bit. So when I run that, what it does is it should reach out to the image feed and then take a photo, then start to measure up all the distance, object location, and then finally give us a JSON block back. So let's give it some time. Great. So let's take a look at the log. It is able to see two objects from the image, and it work out the position of each. Then it produce an image like that with a bounding box saying we have the blue object, the robot here. Then we also have a red object on the right-hand side, and what's the distance between the two objects. And if we look the response, finally, that agent return a JSON block saying some details of image it can see. And then we can use that response feed into our later on, the next one, the planning agent, try to see how the robot can perform different actions. And then the robot can finally get to the object and then perform different tasks. Ooh, so this is the second one. Yeah, we're getting there. We're getting there slowly. So now basically our agent have eyes, it can see the objects. Also earlier, the controller agent gave it ability to move around. What we are now missing is how we actually can combine those two agents together. For example, the observer agent sees what's going on the logo table. Then we have a planner agent able to work out all the step by step. Finally, we run this command all together and we can see the robot in action. So in this case, we do have our next block of code I have, which is to put those three agents together. But in this case, we're doing that in a slow way. So over here, what we have is we have three agents now. We covered observer agent, it can see the fields. Controller agent, it can actually send Python code to the robot and then it can perform actions. And the planner agent is the agent trying to work out how we are able to read the JSON field data and then convert that to movement, for example, forward, backward, turn. And then we will run all these commands one by one. So let's take a look. Hope it will work out. And in this case, we have three agents. However, this agent is just following a very simple way to work together. It's just calling one by one and then feed the response into the next one. And when I run that, it will get a photo first, like our earlier YOLO object. So to give a JSON block back, the JSON just looks like this. It had all the coordinates and the locations. And then it's calling the second step. Second step is sending all this instruction into the planner agent. The planner agent says in order to get to the object, you will only need to move forward 26 centimeters. Then finally, it will send this command into the robot, and then it also tells the agent that the previous reading of the object detection result is no longer valid because I have made some movement. You need to take another photo, so making sure everything is still correct, and then make next movement, make a different decision. Yeah.
The robot itself does not have the camera on the robot. The camera is with the observer agent or
Correct.
Somewhere else in the field of view.
Yeah,
so
yeah.
It sees the whole field of view, and it looks once with your YOLO method. It sees the whole thing and predicts for each grid what what is in there and what it sees, but the robot itself is not seeing anything. It's being told by the other agent. I see.
Yeah,
This
so that's
solves.
one limitation of the robot. The robots, the logo robot, the spec parametry, they do have like distance sensor, color sensor, pressure sensor, but unfortunately, currently they don't have a video camera. So it will be cool if it have a camera, then I can really take it from the robot directly rather than external kind of,
Well, I mean, from a precision perspective, that's better, but from a robot perspective, having a camera on it weighs a lot. How do you power that?
Yeah.
Like this, I'm saying this because, I built a robot previously and it had to carry its own camera and trail its own power lead behind it because a camera plus all the batteries and everything would be too much, especially for Lego. So actually, I really like this this idea that it's not having to carry its own camera.
And it will be harder if the camera is on the robot because the way the sees is more like detect how the robot moves and object has moved. In my case, I actually cheated because the camera is like a god view of what's on the Lego table. It's much easier to detect what objects where they are and the movement. Yeah, just spot on.
Yeah, no, I like that as a solution. It didn't even occur to me to take the camera away from the robot. That makes a lot of sense. Yeah, carry on.
Cool, good. So far what we have got here is we have a few parts of the agent already built. We have got the observer agent, we have the planner agent, also have the control agent. So those three are working together, but currently it is still in a sequential view. So if I go down a little bit. Yeah, so currently those three agents works like this. We have the observer agent able to see what's on the logo table. We got a planner agent. It is able to write the code, make a plan, try to figure out how we can achieve the goal, how the movement look like. Then finally, all these instructions sent to the controller agent. This controller agent calls the robot via Bluetooth, and then you can see the action happening on the logo table. So this is so good. But we still have one problem because how do you, in the end, know the goal is met or not? And also, how do you take a command from a human user? That's when we start to build out a little bit further. What we have done further is we try to put a few more agents into the play. For example, we adding a voice agent using a real-time voice model. It is able to receive your commands. And then we have the orchestrator agent. It is trying to coordinate all different agents, making sure who should be the next agent being invoked, and then what are the output, how do we, in the end, should terminate the whole workflow. Then we have the observer, planner, controller agent in the middle doing the hard work. Then to making sure the goal is actually met or not, we also have a judge agent. It has a set of rules to see is the actual event in the physical world meets the goal the human user give. And then if so, it will then terminate the whole process. Otherwise, it should be tried again, look at the field, and try out different actions again. So all of a sudden, our solution gets a little bit more complex than a single agent or like a few agents in sequential rule. But the good news is, so everything gets a little bit more complex than before. And if we look at these agents from a different perspective, you can see we have the entry point of the voice, orchestrator agent, it is taking care of the memory, the history of the conversation. Then we have our observer agent, it have access to the video camera, planner agent, able to access the knowledge base, found out all the code blocks, snippets can reuse to write the code. Then controller agent, it can talk to the Bluetooth via MCP protocol, send a command to the robot, and then perform the action. Finally, we have a judge agent there to making sure everyone is doing their best to achieve the goal and make a final call. So let's have a look how we can write this in the code. Because in the end, I use the Semantic Kernel framework to help me do all the orchestration. It is not as daunting like you need to write everything yourself because the framework is do the heavy lifting for us.
Does the robot itself have all of the code on the robot?
So what I did is the robot code can be very complex. What I did with the team is we created a library to simplify all different movements. So for example, this is all the raw Python code, the robot to the actions. What we did is rather than you need to, for example, I moving to one action here, it's called move robot. Under the hood to control the physical motor, you actually need to have multiple actions. For example, one wheel going forward at a speed, the other wheel going backward at different speeds. So rather than we make all this complicated code exposed to the end user or the students need to figure it out, we just define a function called a move function. And it takes in a parameter and then can control the speed. So when the robot needs to run the code, this file will be sent into the robot plus the actual MCP call saying what's the distance you need to run. So the code, the MCP protocol need to work out is fairly simple now. It only need to understand to move forward. It just need to call move function. And then the raw physical control code of the Python, it is a part of the library we built. But also we provide the option. I think that's the next stage I'm hoping to do is rather than using these hyper functions, we want the planner agent able to perform any task. For example, it is able to generate this complex code by itself, but we found at the moment it does not always get things correctly. Like you need to spend a lot of effort to explain what are the wheels, how are they installed on the robot, and then also give it the instruction saying what's the distance between the two wheels and how many other modes you have. So yeah, but that's on the roadmap.
Cool.
All right, so I will do the next demo. Let's see everything together. So far we have done a demo that is having everything run one by one, but we want to now do the multi-agent demo. So what this one does is still we are using the semantic kernel, we are using the Foundry agent. What we did is we only input an instruction, a go like that, saying robot to grab the red object and go home. It's a simple command like that. But inside of the code, it has a little bit more inside. What we did is first thing, we are using the semantic kernel agent group chat. In that group chat class, we pass in all the agents available. In this case, it's all the ones we have talked about so far. And also, importantly, what we need to define is two of the strategy. The first strategy is who is the agent to be called next, because it has different steps. In our case, if the observer agent took a screenshot, the image of the field, we want the planner agent to run right after to generate an action plan. And then after that, we want the controller agent to do and perform the action. Then again, we validate screenshot again. That is what that selection strategy does. But in the end, in the code, if I go there, it is just a process you need to map out which happens first and what other agent happen next. So you only need to return the next agent you want to invoke in this way. So that's the first one. That's the selection strategy. The second one is termination strategy, because you need to see if your goal is met. So the whole orchestration can be put to a stop if either everything worked or some task has failed. That is what the termination strategy does. And in my case, I keep everything very simple at this stage. The termination strategy is just looking for the last few chat conversation. If the judge agent has said the action has completed, or the task completed, it means everything is good. But if something failed, then the orchestrator will try to pick it up. Something failed and need to be performed again. But in here, ideal way is you actually can call through into a large language model and then give some instructions. So the language model can even define if the response or the output from earlier step, it is looking correct or there's something not working out as a termination strategy. Okay, so pretty much that's the two hard bit. You now have a group chat. What we do next is we will add our user instruction and kickstart the chat. All we need to do is keep on invoking what is in the chat and then see how the agents play together. Let's okay, so now we have our robot and the object ready on the logo table. And let's test it out how we can do the multi-agent orchestration using the group chat. So what I will do is let's run that. And that is the multi-agent. So I will kick start. So we are passing a goal saying grab the, I think the goal is here. Grab the red object and then go home. So that's the instruction really we give. So the group chat started by that exact command. And the first thing, the orchestrator agent kicked in, asking for an image. And the image look like that. So that's the image that can pick up the objects on it. And then next one is the planner agent. It should make use of the data and then try to perform different, make a plan. So we have all the JSON analysis back. We know the distance between each of them. And then it has started to make a plan. The plan is represented as a JSON block. We can see the robot move forward, and it's supposed to close the arm next. Yep, arm closed, and then should move backward to where it was. Oh, glad it worked. That's cool. And then I think we also should see the chat conversation to stop by itself. So now you can see that there's a second image recognition. And in this case, you can see they are close by. So it says that's good sign. But only the judge agent is able to make that call. And let's see. Yep. So now the judge agent said those two objects. So let's go back a little bit. Yep. Judge agent said go complete it because those two objects is less than a particular defined value. And then we should see all the code stopped going. So the group chat had finished. And then we can see the orchestrator agent jumping as the last one to talk, just give a summarization of what happened. Great. So that's pretty much how the group agent work out. We have like a 5 different agents working together. It only takes one command in the beginning. Then it is able to think about it, look at what's the field, carry out the actual action, and then it knows everything worked out in the end by using the image again.
When you were talking about the group chat between the agents, I was thinking, I was comparing it into my mind between a group chat between developers and architects team members, and just thinking, it'd be on Teams or Slack or Discord, or maybe it's a WhatsApp chat. And then, seeing this chat here, I think that there is a lot less GIFs, jokes, insults, and recommendations that we break for coffee. It's all just like straight to it and doing it. So I could definitely see why they say that AI is going to save us some time.
Yeah, but it actually, I spent a lot of time working on the prompt engineering because what you said actually happened. I saw at a early stage, this agent is not really working out. They are trying to repeat what other agents said again and again. And then also very interestingly, because we need to take 2 photos. What happens is the first observer agent got a JSON block and then put it into the group chat. Then later on, when we want to verify, rather than the observer agent tries to do another photo, the orchestrator jumping saying, here we go, that's the result of the last run. Just use that to do a kind of check again. So a lot of scenario like that, like I did not even think of, just have to do a lot of testing, try to rule them out and improve our pump. So making sure each agent know exactly what they need to do. Yeah.
So you needed a little bit of team building between the agents so that they recognize 100%. Their place and don't just jump ahead and form conclusions without talking to their teammates.
Yeah, that's right. Well said.
Yeah, that's
cool.
Very
Great.
Cool.
Thank you. And we don't stop here. We move one step further. And so far, we are running all the code basically in the script. And we can see with the semantic kernel, the multi-agent orchestration is happening. And it actually controls the logo robot in a physical world and perform some task. But the struggle we had is, if you try to follow all this chat log, it's really difficult. You don't really know who is doing what. And it's very hard for a human to double check, to really see if they are doing the right thing. that's when I thought, oh, we better have a better way, like a user interface, like a web app can help us to visualize what is going on. For example, which agent is doing the work and how this image looks like. And ideally also have the video feed there. So we have human in the loop. We are able to double check and all the code are working and fix bugs, etc. And that's what I used Ripple from Seth and Amanda. They are amazing workshop in Microsoft Build. So what they build is they build a very awesome front end. So let me try to run that. Okay. So it has a front end, a React front end. Okay. And also it has a backend. It's just an API. What we did is that API in the end calling to the same Python script we used earlier to try to do all the orchestration, and also it is able to take a voice input. And the front end looks like this. Here we go. So let me start from home page. Second, let me do a reset so we can start over. Okay, so now we have the front end working. It's a React website, and you can see we start with clicking the speak icon. So that's how the interface looks like. The key things is we have our video camera on the right-hand side seeing the table, and then as the robot agent start to perform, you should see different pictures and the text show up in the interface. So let's get this connected to the Lego robot first.
What would you like the Lego robot to do?
Now we have the welcome message from the agent. I will unmute myself and then give an instruction. Grab the red object and go back to base. Now we
The
can
Lego
see.
robot is working on it. It will grab the red object and return to base. Let's wait for it to complete the task.
Great. The agent is now running. The first thing is the orchestrator asking for some field data. And then the observe agent should be able to take a photo, did analysis, detect object. Now we have the imager recognition response back. You can see we have the robots, we have the red object and the distance between them. Then next step is our planning agent coming, made a plan of 3 actions is required, like a move, close arm, and then move back. We can see the robot is moving. It moved forward. They should close its arm next. Yep, did that. Finally, should go back to home. Cool, great. All right, we have the robot back to home, but we do not finish here. The controller agent said, I have done everything now. Can you please validate and take a new photo? We can see our observer agent start to requesting a new field photo. And once it has the photo, it will do the object detection like earlier. And this time we can see they are so close by. And now the judge agent will come into play saying, okay, good work. You have done.
The Lego robot has completed the task. Would you like to check if everything is in order?
Yep. So judge is happy, saying everything is met. Orchestrator give a summary. And then the voice agent is saying, please human in the loop, do a final check. And I will say, good job.
Thank you. If you need anything else, just let me know.
Cool. I think that's the demo I have.
She sounds so pleased.
Yep, that's good. Glad everything worked out.
That's fantastic. Thank you, Daniel. I think this has been definitely one of the funnest episodes we've ever had. And I really love how it demonstrates that you can use stuff that you want to learn for real world work with your children. And also it gives you a really big justification for why you need a Lego room and why you need to be able to spend as much money as you need to on Lego and robots and hobbies, because it has real world applications. And it's not just that your child is learning how to do this stuff, but you also are able to learn real world skills, because we saw Agentic AI, we saw model context protocol. We saw multiple AI services in use. And and that whole multi-agentic conversation thing, that's really something to see, I think. We're going to put a bunch of resources on our GitHub log for this episode, but is there anything else that you want to add about building apps with AI, or any other advice that you want to give the audience?
Yeah, 100%. I think for me personally, I started to really learn AI about 12 months ago. And when I started, I found the things that are really interesting, especially in my case, I can found it's a good inspiration for my daughter. She is learning and we work together. But also for yourself, if you are interested in AI, want to get started, start with some simple repos on the GitHub. That's always a good start point, because once you get started, you can keep on building it and then learn more as you go. Don't try to build something too difficult in the beginning. Start using all the accelerators, other people's repo, and then you will find the things actually is not as hard as you would think, especially a lot of resources are available. And in my case, what I really enjoy the whole exercise is I'm able to integrate the different resources together, because there are so many good repo out there, demo, example, and also from Microsoft, if you go to Foundry portal, you can see that list of ready builder and repo you can use and make changes. And then if you can actually find your next $1 million AI agent idea, start building. And don't forget to buy us a coffee if you really made it that far. Yeah. Thank you.
Yeah, because the first version of the robot that you built was just object detection, but now there's like multiple things, including the voice stuff as well. So yeah, absolutely love that idea of start simple with just one thing, and then add on each agent at a time. And it's not that difficult when you look at it in those small blocks. So yeah, fantastic. Daniel and I are going to stick around a little bit longer to answer questions online. Thank you for joining us, and we look forward to seeing you again next month. Bye, everyone. Thanks,
everyone.
Daniel.
Thanks, Michelle.